Okay, so let's just look at these two problems here where they give me a limit sigma definition, and we're going to try to somehow rewrite it as a definite integral. So we got to translate each of the things. So these are the steps that you want to go through. Step 1 is find out what delta x is. So that's the width of the rectangle. So dx in this problem, okay, notice they are giving me the limit sigma. So think about what the limit sigma definition is. It looks like this. Oops. Okay, this is something that gets multiplied through by the function every single time. And what you should notice is, oh, if I replace that 1 with k, I'm taking that and squaring it. That's your f of x sub k. The other way to think about it, your dx should be a number on the top because it's the upper bound minus the lower bound. Remember, is b minus a divided by n. So it's got to be a number divided by n, and it's getting multiplied everywhere through. So usually that's kind of the easiest thing to pick out in the beginning. So I always start with that. So dx here is 1 over n. Okay, you have to figure out what x sub k is. Okay, sometimes you can figure it out right away. If you're not sure, I mean, just look what's happening. It's where the k has to be. So your x values are going from 1 over n, 2 over n, 3 over n, all the way to n over n, right? Your k is your counter. So your x sub k is really k over n. Your f of x sub k is, what are we doing to your x? We are taking it and squaring it, right? I'm taking x sub k and squaring it. Now the last piece that we need, so this is the same as x squared. There's that piece right there. This is just my dx. The only other thing that we need is our bounds. This is the way to do the bounds. This is our first x coordinate. So 1 over n, and n is the number of rectangles. If you take that limit, that will give you your first x coordinate, which is 0. And then this is the last x coordinate that we're using. So if you take that limit, that will give you your upper bound, or the last rectangle. So this has to go from 0 to 1. So this is the definite integral that matches. Okay. Let's try the next one. So notice here, I noticed my dx looks like it's going to be 2 over n. Notice that's your k. So there's going to be a couple different ways you can do this. So let's say I called x sub k everything underneath the function. Then my f of x sub k would be, oops, notice what am I doing to all of this? I'm taking the square root of it. So there's my function. My bounds, oops, would be, if I take this, plug in 1 for k, your first x coordinate would be this. So there's your first x coordinate. Your last x coordinate would be the upper bound, would be if I plug in n for k, and this gives me 6. So this is the same as going from 4 to 6. There's my f of x, and then this is my dx. So this is a way to rewrite the definite integral. Okay, now there is another way to rewrite this, because you can pick a different f of x. Okay, so let's try this one another way. So same thing, dx doesn't change. dx is still 2 over n. That's the only thing I can see that's getting multiplied through, b minus a over n. Your x sub k actually can just be this piece, right? The 4 is not changing, so if you want, you can make it be this. But then your f of x sub k would be the square root of 4 plus this is your x sub k. So that's the x piece that's changing. I mean, really, to be correct, I should write that. So, but then when I do my bounds, here's my x sub k. My first x coordinate is going to be plug in 1 for k. So this limit is 0. And then plug in n for k. So this limit is 2. So notice here, I get this. These and these graphs are exactly, they're the same graphs, but you're looking at a different interval. But think about what this graph is. This is the square root of x from 4 to 6. That's that graph. So I'm looking for the area underneath the curve here. This graph, I'm moving to the left, right? That's what that plus 4 does. And I'm looking from 0 to 2. Notice it's the same region we're talking about. So there's different ways to write the definite integral. Most of these times are multiple choice, so you'll have to look at the answer choices and check them.